Okay, we're started. All right. Well, everybody, welcome. This is today's Thursday, December 16th here in Los Angeles. It's 1:06 p.m. and we have a really exciting meeting of our monthly ELIT reading group for you today. And before we get started on with our guests and we introduce you to everybody, I'm just going to tell you a little bit about what this thing is, and then make a few announcements, and then we'll get to our presentation for today. So those of you who are watching the video, feel free to skip. Well, you're probably already watching at 1.5 speed. So so this is the monthly ELIT reading group, and that is an informal gathering of folks when we're in person that are around USC, sponsored by the Humanities and Critical Code Studies Lab, which I direct, and which a lot of these people are members of or affiliates of. And we meet once a month to talk about electronic literature of one kind or another, and related topics, I should say, as you'll see from today. And this group's been going on for a couple of years. And if you would like to be on the mailing list, just send me an email. My email is markcmarino@gmail.com, and we'll add you to the list. And again, we're always welcome to have newcomers as well. And just really, we're amazed. It's amazing to see all the people who've gathered today for this session. So we kind of alternate between small group sessions where it's just sort of the local folks, and then, larger presentations, but everybody's welcome to any of them, of course. So before we get started, I just want to make a couple of announcements of things that may be of interest to you. And then I will try to, probably after I make these announcements, I'll put links in the chat that are related, but I want to make sure I get them all and get them all correctly. So first of all, my dear friend and collaborator, Rob Wittig, just published his new book, NetProv, Networked Improvised Literature for the Classroom and Beyond. And that's out from Amherst Press. But the real news about that is it's available for free online. So go out and, let's do that. Let's enable live transcripts. So again, just so it's caught by the transcript, this is Rob Wittig with a new book he's got called NetProv, Networked Improvised Literature for the Classroom and Beyond, available for free through Amherst Press online. So I recommend that's a great thing to take a look at, or you can pick it up for a stocking stuffer, of course, or just read it for free, which is probably a great way to read things, of course. Also coming up, we have a January 7th deadline for the 2022 ELO, Electronic Literature Organization Conference in Como, Italy, and online. So the deadline for that is January 7th, and that's a great place to submit panels, presentations, works, performances, all on the related to electronic literature. And it does have a kind of an education theme this time around. So I'll put the call in the chat if it's not there already for you to check out, but I hope you'll submit something. And again, that's both in person and hybrid. So if you can't make it, then which would be great to make it to Como, Italy, I would think. But if you can't, you could be online. Also, we're at yesterday, the deadline passed, or the deadline arrived for the 2022 Critical Code Studies Working Group. And this is a biennial event that we host through the HACS Lab, and also in coordination with Jeremy's lab up in Santa Barbara. And this is really the one time every 2 years that we get together online for about 3 or 4 weeks in a discussion forum to take on topics of interest of code studies. And a lot of work gets done here. Sometimes we'll write a book, like, 10 print came out in many ways. The book 10 print was born of a critical code studies working group. And sometimes we'll just do a group exploration of work that, again, just might stand on its own, or we might, as we did with Adventure or the code from the Apollo lander. But anyone who participates in that, we invite to start discussions of threads of code. And of course, we've had discussions of esoteric programming languages has been something really from the get-go. Now, I say that the deadline has passed, but we have some flexibility. So if you missed the call and you want to apply to it and join us, please do fill out the application. I'll put the link in the chat in just a little bit. Now, people who are watching this on video, you might be too late, especially if it's like 2023. Please don't apply. Last but not least, the long list for the new Media Writing Prize. This is an annual prize that's offered out of the UK that comes with some money, by the way. They have their long listed works for you to vote on. There's an award that's given based on people's choice. So please consider going and at least take a look at those works and maybe vote for them. Also, if you're a student, an undergraduate, you can still submit a work. The deadline is tomorrow for that. So I invite you to submit a work, and it's a wonderful contest that certainly opens up electronic literature to wider audiences and brings in pieces of all sorts. All right, I think those are all of our announcements. Regular group, did I forget anything that you think I should mention?
Did you did you tease the sunshine logo?
I haven't. I guess I could. So largely because we haven't settled on a logo yet, have we? Or I have my favorites.
Well, maybe for next time then.
Okay. Well, what I will tease without the logo, since the logo is still in development, is we have a new group or team that is emerging out of sponsored by the Humanities and Critical Code Studies Lab. And this new team is kind of an action-oriented group that is advocating for the exploration of computer source code, but also maybe the release of some code for investigation. So, for example, we'd love to see some code of predictive policing software that's used in precincts, that sort of thing. Anyway, that group, which is adjacent to similar groups like the Algorithmic Justice League, is called, get ready, the Sunshine Source Force. And I don't know how forces work exactly. I assume there'll be some sort of recruiting events. But there'll be definitely more information that emerges about that over the coming months, especially during the working group. I think that's probably when we'll do our true launch of some sort. But yeah, there's a logo in development and a Twitter account so far. So keep your eyes out for those. All right. Very good. So now let's get to our main event without any delay. So it's my great pleasure to start this session on esoteric programming languages.
Hey, where's Delaney?
And
in the meantime, I'm accepting.
Someone may want to mute. I'm not, because I don't know where Delaney is. But anyway, getting back. It's my great pleasure to introduce you to this topic or to welcome you to a discussion of esoteric programming languages. It's really relevant that Jeremy Douglas is here, who's my really close collaborator on all things critical code studies, because he was the person who first showed me a lot of the programming languages that we'll be talking about, or that are in this category that we'll be talking about. But then, of course, one day, and I was trying to figure out where this was, if it was in Cork, Ireland, Daniel, or was it in Porto? Do you remember which conference it was?
It was the one in Cork.
Okay. So again, speaking of the Electronic Literature Organization, Daniel and I first met in Cork, Ireland, at the conference there, where I was first introduced to his website, a bookish zine-ish book he had put together, and of course his tremendous love and affinity for esoteric programming languages. And that's led to many conversations. So let me tell you a little about Daniel. So Daniel makes photography, programming languages, net art, and paintings, examining the clash between systemic logic and human. He's written about programming languages as an art form for Hyperallergic, Leonardo, and World Picture Journal. His blog, which we need to get in the chat, Esoteric Codes, it was the recipients of the artswriters.org grant. And it presents artists and writers and hackers who challenge conventional notions of computing. It was exhibited recently at ZKM and written at the New Museum's New Ink Incubator. And I don't know if I mentioned, but it was presented at the New Museum, SIGGRAPH, South by Southwest, Media Art History. Anyway, this blog has gotten around, this website, as it should. It's really wonderful. He received his MFA from ICP Bard, and he exhibited at ZKM, Toma Art House, Museo de Teatro Dumbo Arts Fest, Glassbox Gallery, and he was a critic's art pick for Art News and New York Times and Boston Globe. But also something you should pay attention to, Angelinos, on January 15th, a show of his that he's a part of opens, the Digital Combines. It's opening at Honor Fraser, which is on La Cienega. So I'll put information about that in the chat as well. So we're gonna have Daniel go first. He's gonna give his presentation, and then we'll come back and I'll introduce Catherine to you for part 2 of our presentation today. Welcome, Daniel.
Thank you. All right, so just one sort of awkward moment here when I try to get my keynote to play. Okay, so do people see that? Oops.
Not yet.
Sorry, I think I lost everybody for a second. Can you still hear me?
We can. We see you, not your
okay.
keynote.
Yeah, sorry, I just killed it because I can't, for some reason, I can't see you when the keynote is up. So when nobody's talking, I don't really know if people can still see it. So let me bring this back up again one more time. Sorry about that. Oh my gosh, this is really...
Daniel, sometimes I drag the window into the second desktop and then maximize it, and that works for the play setting.
Yeah, that would make sense, right? This was all like really easy when we were practicing it.
No, this is a great,
Okay.
We're modeling what life is like in the digital arts.
Nobody sees anything, right?
Not
Just
yet.
your purple background.
That's
Although
my purple background. Yeah.
Yeah.
Right.
Or switch
Sorry.
the display over to combine displays. That could also, that also works for me sometimes.
Okay, we'll just edit this video later, so it just looks like it went really smoothly.
Oh yeah, here I'll pause it till it's ready.
Oh right, and I can actually see you all now too, so that's really great too. Okay, so sorry everybody again. I'm Daniel Temkin, and I'm going to give you a very short and very sort of focused for the ELIT crowd introduction to esoteric codes, to esolangs rather. So Esoteric Codes is my blog. It began with a series of interviews that I did starting in 2011. So in 2011, I'd made a couple of esoteric programming languages, and I was trying to get other artist friends and people in my MFA program to sort of understand what I was doing and what the context is for the work, and just really what's going on. And I found that most of the writing about esolangs was very technical and didn't really get into concept in a really sort of interesting way. And I think the writing has changed since then, but this is sort of what the landscape looked like back then. So I started interviewing esolangers and really sort of avoided asking technical questions and tried to get them to talk more about their ideas and how they influence each other and so on. So I'm going to give you a little bit of an introduction to this. I'm going to start with a few early esolangs that kind of helped shape the kind of movement of work around this. And then I'm going to talk about multi-coding esolangs, which is probably the type of esolang that I'm guessing is going to tie in most closely with what Catherine is doing, and maybe with what a lot of you are familiar with. And then if there's time, we can get into a few other sort of categories of esolangs. So in terms of the early esolangs, in 1993, this language false appeared. It was created by Wouter van Ortmerson, who had already created a very popular language for the Amiga called Amiga E, which became one of the most popular languages for the Amiga. And it was created when he was really still a hobbyist. Later, he went on to get his PhD in computer science and sort of get deeper into language design. But he had already created this very popular language. And as a follow-up, he decided to create a language that would be useful in as small an implementation as possible. And by useful, it means that you can write a wide variety of algorithms in this language. And he did this with sort of the constraint that the compiler would be 1K for the Amiga. And what he ended up with was this language where it offers quite a lot of features for what would later be called SLANgs, but everything is expressed, all the commands are single letters. That was one of the sort of things he had to do to get this to function in such a small executable. And it has this, very basic kind of architecture. He offers you a stack. He offers you 26 variables that are named A to Z, so that you don't have to do any sort of name variables and so on. And of course, SLANgs didn't really exist yet at this time. The word SLAng hadn't been coined yet. So this was just sort of an experiment of how much he could do in this very small space. It's named for his favorite truth value, false. And it's Turing complete, which just means that any algorithm you can express in a language like C++, you can actually express in this language of false. It would just take it'd just be much more difficult. It'd be much more spelled out. And so when false appeared, 2 other languages were created in response that both became some of the best known SLANgs. One of them is bfunge, which was created by Chris Pressey. And Chris really kind of latched on to this idea of commands being a single letter. And he said, well, now that we can express something with a single letter, we can have program flow that doesn't run across one line and then go to the next line and sort of reading everything in order. We now have this grid of letters as our source, and we can have an instruction pointer that sort of moves in different directions across it. So when you're running a bfunge program, if you have a caret, it turns the direction of the reading of the program upwards. If you have a lowercase v, it goes downwards. The greater than symbol moves to the right, and so on. And this is something that was only really possible once you sort of go to the single character setup. Looks like this video stopped. There, you can see this kind of flowing. This is going to draw a little picture. If this thing ever completes, well, I'm just going to kind of speed it ahead. Eventually, this moves through this whole thing and draws this little image at the end. But anyway, basically, I just want to show how the program flow goes through this thing. So this was him sort of latching onto one aspect of false and sort of seeing how far he could go with it. And this created a new sort of category of what would become SLAs called funges. And funges are basically languages where that instruction pointer can move in all these different directions. If it goes off the screen or off the source code to the right, it comes back to the beginning of the line on the left. You can go off the top and appear at the bottom. And while bfunge is in a grid, there are 3D versions of it and 4D versions of it. And there's a 1D version of it where it's just one line of code and the instructions just go in order, and it might go backwards and it goes forward again. And so in the 2D version, if you have an if statement, you're literally just like it hits that if statement, and depending on the conditions at that moment, it'll either go up or down depending on what's at the top of the stack, or it might go left or right depending on that. So it's just a new form of programming that he invented based on this. And the other language that came out, and this is all 1993, and this is all for the Amiga, is brainfuck, which is probably the best known SLang. It's definitely the kind of the most notorious language. And this was created by Urban Mueller. And he looked at false and he said, well, false is 1K. He said, I can create a Turing complete language that's a quarter of that size in 256 bytes. Instead of packing in a lot of functionality into 1K, like Van Ortmerson did, Mueller decided to just give you just what you really need to be able to have a Turing complete language. And what's interesting about brainfuck is that its model of the computer, the kind of virtual machine that it offers, is very simple and very easy to understand. It's just a bunch of memory blocks, and each of them has a number that's between 0 and 255. They all initialize to 0. And all you do to write a program is move back and forth along this array and change those numbers. All you can do is you can add one or subtract one, but the plus sign adds one, the minus sign subtracts one. The angle brackets move back and forth to the left or right. And then you have this, the square brackets are both an if statement and a loop. If where the memory cell you're sitting on is 0, it jumps to the end of that block. Otherwise, it will do that loop, and it'll keep doing it until it's sitting in a place that's pointing to 0. So basically, what comes out of like one way to think about why brainfuck caught on so much and why there's been such a response is that it really feels like a return to the kind of early computing that style of code that we're really have been taught not to code in anymore. Dijkstra had this essay in 1972 telling people that we're no longer in the era when you have to write code that's particular to one machine, or we need to have clever tricks that take advantage to get to get your algorithm to run a little bit faster. It's much better to write code in a way that's very clear that you'll understand when you come back to it a year later, or that other people will understand. He said, let's kind of professionalize computing. Like this essay begins with him talking about entering the programming profession and how that profession didn't really exist in the Dutch system at the time. And he's sort of like, okay, let's make programming professional. And the way to do that is to, as he says, the competent programmer is fully aware of the strictly limited size of his own skull. Therefore, he approaches the programming task in full humility. And among other things, he avoids clever tricks like the plague. But with these languages like brainfuck, there isn't really any way to write code that's very clear. And you have to be clever to get anything done at all. So for instance, these are 5 different ways to get to the number 35. If you want the number 35, you could have 35 plus signs, which will get you to 35. But now you're using 35 characters. Well, here are different ways to get to 35 using only 18 characters for the first example, or only 14 characters for the last. Now, people who get used to brainfuck can look at this top example and sort of understand that this is going to get to 35.
I'm pretty excited about it.
Because they'll see that the 5 before the bracket, and they'll see the 7 inside, and they'll sort of recognize this pattern and say, okay, this is multiplication. We're multiplying 7 by 5. But the bottom one, no matter how good you are at brainfuck, you're not going to be able to understand this until you actually run the algorithm, unless you really work it out very carefully. And while the top one uses 2 memory cells to get to 35, the bottom one uses 12. And it gets there by wrapping. Wrapping means you go past 0, because when you get to 255 and you add 1, you get back to 0 again, and so on. So basically, with brainfuck, you have to sort of break away from the sort of day-to-day code where we're trying to write code as clearly as possible, and we get to be clever. We got to work in the style that had been sort of it isn't considered professional anymore. But the other thing that's sort of important about this is that Mueller did not discover all these different ways of writing 35. Brainfuck was created in a relatively short amount of time, and Mueller sort of disappeared from the scene pretty early. It was a whole bunch of other programmers who were inspired by brainfuck and decided to experiment with it, who discovered how to write algorithms in it. And so the only way to sort of really understand sort of the aesthetic of brainfuck is by the work of all these people who have discovered these algorithms and sort of figured out how to actually code in it. So just one other point I want to make, there have been many, many variations of brainfuck over the years. The first sort of brainfuck derivative language is Ook, which is a replacement of each of the symbols with these orangutan noises. So the left caret becomes question mark, period. And what happens when you do this is now you're sort of just messing with the lexicon itself. Underneath this is still brainfuck. The logic is all the same, but now it becomes really just impossible to read. And this is something where, you can see that it was sort of intended to undermine the kind of self-seriousness of programming. It's like, okay, we're just going to sit here and make orangutan sounds, and this is what our code looks like. But also it completely obfuscates the code. And you might think that this is sort of limited, like messing around with the lexicon itself, but keeping the same backend. How interesting can that be? Well, that actually can become very interesting if you kind of go a different direction with that. And that leads us into multi-coding. So multi-coding is an idea that really came out of the Box Darkly essay by Matthias and Montfort, where I think they called it multiple coding, which is the idea that you can have one text that has a valid reading in more than one system that will be sort of grammatical in two different systems, but with different meanings. So this is a sentence that can be read in either French or English. This is the example they had in the essay. And in these two different systems of interpretation, it has two very different meanings. I guess in French, it says that Jean is able to say how one types. So the multi-coding SLANGs are SLANGs where coding within that system always involves a reading in a completely different system. It could be like, I could make a version of C where things will work as valid C programs, but additionally, they have this other meaning as the secondary programming language. But the more common approach with multi-coding is for it to have a meaning outside of programming entirely. So one of the early examples is this language Chef by David Morgan Marr. And this is a language where code appears as a cooking recipe. And Chef is kind of interesting from the beginning because, in a sense, recipes are already algorithmic. They break up the continual action of cooking into these discrete, repeatable steps. With a recipe, I should be able to produce the same results each time if I start with the same beginning state, the same ingredients. So it already is creating this sort of metaphor. But when we talk about the aesthetics of Chef, how this works as a multi-coding system, we have to consider both how the programs work in the computer and how they work as actual recipes. And now when Morgan Moore created this, he wanted the recipes to look convincing, but he didn't really expect people to actually cook them and actually design chef recipes that you could actually eat. But of course, the language became much more interesting when people started to do that. The language became much more popular than he was expecting. And Ian Bogus has been teaching this to his creative coding students for a long time. So he's had many people create these recipes. This is one that was made for his class. This is a program that squares an input number and it also produces these Irish cream dessert squares. You might look at this and it might look like a very sort of ordinary recipe, but of course this requires exactly 61 white chocolate chips. If you give it 63 white chocolate chips, then the output of the program is going to be off by 2, because that's the offset between a number and where that number falls in the ASCII table when you print it. So the way, what we can think of as the aesthetic of Chef really comes from the group of programs and recipes that we would make within Chef. And it also comes from the way that those two systems map together. So when you take something from the refrigerator, that is also how you get input from the user. If you take 3 eggs from the refrigerator, you might need exactly 3 eggs for your recipe to work, but the 3 is immediately overwritten by whatever number the user has put in. So it functions a little bit differently between the two systems. Chef, it turns out, works very well for baking. There's a lot of mixing bowls involved. You might deal with more mixing bowls than you would really need to be able to accomplish the recipe. And there's this liquefying step that comes up a lot in these programs. So it's very sort of baking oriented. David Morgan Moore also created Pete, which is one of the best known multi-coding languages. This is a language where the code is written as an image, and it's the change in color and brightness from one block of color to the next that determines commands. And so we can kind of think of these languages as kind of the opposite of generative art. Instead of having an algorithm that generates a whole bunch of different images, we have a rule set, and then people have to sort of manually create programs that work within that rule set. And so one comparison we can make is to the Aleppo experimental writers and the idea of constraint-based writing, which is sort of very similar to this. You know, if you set out the example of writing a lipogrammatic novel to write a novel in French without using the letter E, that's sort of an interesting provocation. But the way we can really understand it is by looking at the novel that Georges Perec actually wrote to see how that actually plays out. And the same thing for Pete. We can look at a whole bunch of these different programs that people have written for Pete and get an idea of what the aesthetic of the language is. So the ones at the bottom left and the bottom middle are sort of somewhat more typical of what Pete programs look like. The one to the right was created with a Pete generator where you can put in pseudocode and it'll actually generate a Pete program. And then the one to the upper left is a program that actually calculates pi. And it calculates pi using that red vertical line to the upper left, which is the radius and the circle itself. So basically, the larger that you draw this program, the more accurate digits of pi it'll be able to calculate, because it's using the actual image of the circle to represent the circle in code. And it's really sort of flattens that metaphor at the center of Pete between the image and the behavior of that code. So I'm going to mention one of my multi-coding SLAs. Multi-coding was really my introduction to SLAs. And in 2012, I was in art school in photography, and I created a programming language where a series of images, it's actually a directory full of JPEGs read in alphabetical order, are the code. It's called light pattern. And this is a somewhat typical light pattern program. These images were shot in the room that I'm in now, so you can kind of see what the reverse angle is, what I'm looking at right now. And this was based on the Fluxus event score Fly by Yoko Ono. And I wanted to, so I had a series where I took these event scores and I performed the score in a way that photographed, they would write the score to the screen. So I'm kind of reversing, instead of performing it based on the score, I'm performing it to actually create the score. So this is a program that will print Fly to the screen. And I made this happen by making my camera fly, throwing it up in the air over and over again with colored gels to force it to be the dominant color to be red, green, or blue, which is sort of important for light pattern. So one thing I wanted to mention about this, many of the programs for light pattern tend to be really have this sort of very dominant red, green, and blue images, but they don't have to. This program could have been written by taking a whole bunch of Flickr images and just arranging them in the correct order, so that ones that have slightly more red will be the red images, ones that are slightly darker and blue might be the next image, and so on. The idea was that rather than having an aesthetic that was quite as obvious as some of these other examples, I wanted light pattern for it to be very sort of open-ended, where it didn't have to look a certain way. It's just a relationship between these consecutive images, and it's up to the programmer to connect the way the images look and their performance in a sort of very open-ended way. And so I know I'm sort of at 20 minutes right now. I'm just going to quickly mention two kind of more text-based SLAs for the ELIT crowd here. Esopo is a series of multi-coding languages by Will Hicks, which is named for the combination of Oulipo and SLAs. One of those languages is called Ash Paper. This is a factorial program. And Ash Paper, the commands in Ash Paper are things like rhyming from one line to the next, having certain punctuation in the middle of a line, having capital letters at the beginning of a word or in the middle of a word. So things that poets might do anyway. Like or as also have special meaning. So the idea is that you could write poems that feel natural as poetry, that don't necessarily become really dominated by the aesthetic of Esopo. So ones that are sort of a little bit more open-ended. And then finally, I want to mention Inverse, which is a project by Sukanya Aneha, is created about 2 years ago. And Sukanya decided to make things sort of a little bit simpler for the programmer poet who approaches her language by, instead of having something as specific as the rhyming or punctuation, having a word table that can be different for each program. So while if you want to refer to X in this poem, it's the word harvest, but for another poem, it could be assigned something different. So the program is both made up of the text of code here and then also the associated word table. And also the output of this is a shader. So we get images, moving images or still images as the output instead of some of these other SLNgs that can be used to do sort of more basic computer functions. So I think that's it for me. I just want to mention very quickly that I'm always looking for new material for esoteric codes. So when people see really cool projects, SLNgs or anything sort of related, to please send it my way.
Oh my goodness. Thank you, Daniel. Too awesome, too fascinating, too many questions. But now we're gonna, speaking of baking, we're gonna turn this into to Chopped or a cooking show. So for the past few years, Katherine has had some ingredients and she's been cooking up her own Esolang that she's gonna present to this little celebrity chef for his tasting, I guess, and to us all. So let me introduce you to Katherine, our next speaker. So let me tell you a little story first about Katherine. Katherine's an undergraduate at USC. And when I first met Katherine, she contacted me about what was going on at the Hacks Lab. And this happened to be, I believe it was in the summer of 2020. So, a pandemic had just happened. And also the Critical Code Studies book had just come out. And she said, oh, I've just found out about this lab and I want to get involved. What are you going to do? And I didn't have any plans at all for what to do next. And so many of the things that have happened since then, including the anti-racist reading group, these various talks, and maybe even the Sunshine Source Force, are all inspired by Katherine saying, when's this lab gonna kick into gear so we can all be involved in something? But let me tell you a little bit about her. Katherine's a creative technologist interested in soft tech and poetic tools. Born and raised in Hong Kong, she is currently a senior at the University of Southern California, where she gathers different theories and practices in a hodgepodge of media arts, computer programming, and linguistics. Her favorite mottos include move slow and fix things, and don't tell the poets. Her other particular research interests include critical code studies, internet culture and language, interface aesthetics, electronic literature, and accessibility. And then one more thing too, that speaking of the Electronic Literature Organization, Katherine also had a piece in one of the exhibits in ELO 2021 as well, which you can check out. But anyway, now let me turn things over to Katherine.
Thank you so much, Mark. So happy to be here among so many great people, and thank you all for coming. Okay, so can you all see my presentation slides? Okay, great. Okay, so this is my project. It's called Koem. As you might be able to guess, it's a portmanteau of code and poem, pretty straightforward. This is actually my senior thesis. So I just presented this in a faculty critique session a couple days ago. So been mired in it for a while recently. And I'm still working on it. I'm still thinking through some concepts and working out some kinks. And I definitely don't know as much about SLNgs as Daniel does. So bear with me, I'm still learning and exploring different things, but let's get into it. So here's this animation. when I was trying to think of what to do for my thesis, I was sort of thinking about the two things that I'm most passionate about in work and life, which are sort of very generally described as poetry and coding. And I was thinking of these different adjectives and emotions that they make me feel. And these are sort of like a representation of each of the circles, and then sort of like a Venn diagram of how they might come together. And I was thinking of ways that I might be able to fill in or do something to fill in the middle section of that Venn diagram. Like, what would it look like if I did something that really combined the two, and what emotions could I sort of draw from both sides in making that project? And I think what really drew me to both sides is that coding sort of gives me a sense of agency. Like, it's sort of that feeling of doing a jigsaw puzzle, and you know that all the pieces have a place in the puzzle, and you sort of, when you put that final piece in, it's that feeling of satisfaction that you've been working towards that purpose. And then poetry on the other side is just sort of raw expression. It's sort of like a reminder of like being human and everything that comes with it. So I was thinking, what would be sort of a way to combine that feeling of agency and purpose, but also raw emotion. And so there are also some, I've been sort of exploring different ideas that people have been sharing on Twitter and other places. And for my friend Leslie, who is here in this Zoom, this is something that she wrote that really captured my imagination. Just different thoughts about sort of what it's like to use a programming language, the sort of the way that coding is sort of perceived as something cold and emotionless, but like we inevitably bring our humanness and emotion into it. All of that was really sort of percolating in my mind as I was working through this. So here's sort of the log line. Koem is an esoteric programming language that seeks to explore ways that poetry can be made purposeful and ways that code can be made emotional. So here are sort of some of the questions that I was sort of exploring, thinking about the aesthetics and poetics of both of these things. How can they be blended? Thinking about different paradigms of code and reimagining them. Thinking about what a programming language intended for poetry would look like. This was the challenge that I was setting for myself, is the way I framed it. This one is sort of particularly what I've been thinking about recently. I'm sort of realizing maybe that maybe it's not sort of a fully programming language. I'm sort of, I've listed these areas here because I'm not super sure if it, sort of what domain it belongs in. I'm thinking now maybe it's a step up from code poetry, but not quite to a Turing complete programming language. But maybe we can chat about that later. So obviously, here are some of my inspirations. Two of them are projects that Daniel just talked about. And then here's also the Shakespeare programming language, which is a classic one from the early 2000s that uses Shakespearean language to write commands. So here's sort of the outline of my project. It's in 3 parts. The main one is the language, but I've also been developing some of the other resources for sharing it with the public. Here are sort of the features that I've been thinking about in developing my language. So regular expressions are one of my favorite things, which is sort of a controversial thing to say, but I think they're really interesting, and I really wanted to see what kind of poetic potential could be pulled out of them. And then another one of my loves is typography. So I've really tried to like put a focus on textual elements here. Yeah, just sort of generally thinking about interaction and interpretation, and how to sort of forge a relationship between the human programmer and the sort of functional machine. Okay, and so I wanted to jump over here into my website. So this is a website, koemlang.org. You may visit it if you would like to. The homepage, I have a learn section that sort of outlines sort of basic patterns of how the language works. But I wanted to jump into an example to show you like what it would look like. So here's a poem. The way that it is structured is that the left side is the source. So this is what you as a human programmer would write. And then the right side would be sort of the output area. And I don't have the right side flushed out very well yet, but the idea would be that it would be a bit of a sort of a collaboration effort, and the final sort of product would be meant to be read as a side-by-side source and output. But I'm just going to take a minute to step through this sort of line by line and explain to you what's happening. So it starts off with a comment, and if you hover over each of the elements, you can see what exactly they are. So the first one is a comment. The operative that denotes what a comment is either a star or an asterisk. So this is sort of borrowed from how we know in the literary sense, where stars and asterisks are symbols that we use in footnotes. So that sort of gives a sense of its additional information, which I've translated as comments. And the reason I'm able to use asterisk here is that I don't have any math in the language, which is a bit unusual for a programming language, which is why I'm not sure if it is a programming language. But without math, the symbol is sort of freed up to be something else, which is a comment. Here on the second line, I'm declaring a variable. So here's the word let, which we know from other languages like JavaScript. But I've tried to be really deliberate in thinking about what specific lexemes I want to borrow and use. And the reason I wanted to use let is because I just learned this. It's something called an optative mood, which is sort of like, it's a grammatical thing that describes you sort of wishing for some kind of action. So this is sort of like, instead of sort of imperatively saying or imperatively declaring that this variable is this now, you're sort of, it's more of an expression, a wish that you're putting out into the world that this thing is going to be this value. And then following that variable declaration keyword, we have a variable name. And what's special about variable names in this language is that you can use regex, regular expressions. And the way that, what regex is a sequence of characters that describe sort of a pattern of strings. It's a little hard to describe abstractly, but let me explain to you what this is. So this is me, and then a pipe symbol, myself, a pipe symbol, and then I. And basically that means it will match either me, myself, or I. So when you declare a variable, you can set it to some kind of regex expression, and then every time you refer to it in the following lines, you can use any of those sort of typed sub expressions. So here, if I say I, and then here, if I say myself, they're both referring to this variable right here. Okay, and then this is sort of self-explanatory. This is a while statement, which is pretty standard. I've tried to also sort of bring in some sort of typographical quirks. So this is an M dash. If you're not familiar, there's hyphen in English, or in sort of typography, we have hyphen, N dash, and M dash. And M dash is sort of used for separating thoughts. It's sort of similar to maybe parentheses. So I've used that to replace parentheses here to sort of represent separating thoughts. And so here we have some additional information, which is the list of arguments, or sort of describing the condition in this case for this while statement. And then et cetera, et cetera. Moving down here, we have a function declaration. So the word to begins the function declaration. And the way that I've sort of thought about it is that variables are nouns and functions are verbs. So sort of this is a noun, this is a verb. A function is sort of a method, an action, a way to do something. So that's sort of like how I would use these patterns in my language. And then another comment, here's an alias for the print function. So I have print, no, and say. So those are, I've just tried to build in some aliases to sort of give the programmer poet some more flexibility in expression, and also sort of make a statement about like what printing is, like what these different paradigms mean or feel like to us. And then finally, this returns a value from the function, and here we're returning nothing, which is sort of an alias for null. So that's the whole poem. I have a walkthrough here that you can read if you want to, if anything wasn't clear in what I just said. But that's that. And then I have some reference materials here. I'm still working on building a lot of these materials. Eventually, I will have an editor where you will be able to write the code and play with it and sort of get a sense of what it is to, how it is to type it. That's the website. These are sort of the poems that I've written so far. In terms of moving forward, I'm still working on it. So I'd love to hear, if we do have any time for a discussion, I know we're running out, how this sparks your imagination, what does it make you want to do, and what kind of materials would help you learn or play with the language. Thank you. These are my socials. Thank you for listening.
Oh, that was delightful. Snaps and claps all around. Katherine, thank you for sharing that with us. This is a ELIT monthly reading group first. I think it's a Hacks Lab first as well that we're getting this demo of a new language. Now, if I can, now I'm going to bring out our celebrity chef who's been listening this whole time to this brand new Esselang. This is the first time he's seen it, by the way. We just took it right out of the oven. We served it up to him. And Daniel, what are your thoughts about this brand new language you just saw?
Oh, it's very cool. I love the way that it's presented. And I'm excited about the possibilities of it. I have some questions. I do it maybe some suggestions, but I guess the first thing I want to ask is, so it seems like you said that you want to avoid math. And that kind of makes sense because there are a lot of Esselangs that are sort of poetry type Esselangs that get very messy when you start to deal with numbers. And all of a sudden you need to either expressly list those numbers in the code, or you have to have these sort of long combinations of words in order to express them, and it can get really complicated. So I see why you want to sort of work away from that. But and I think that's fine. I think that could be a good decision. But in terms of the behavior of the programs, what these poems should do when they run, do you have an idea of what that is, and how important is the connection between the way the poems read and how they execute?
Yeah, I think so. This is something I've only recently sort of realized about the language, that it isn't really that basically it's not Turing complete, that it doesn't do any math, it doesn't perform any computation really. But that's why I've sort of started to frame it as sort of like an experiment in truth and expression, in that it's not really about sort of performing some kind of algorithm, but more about it's sort of more about the act of writing the poem and knowing that all of these words are sort of functional. And I think that's the main point of it right now, but I am still planning on building out another feature of the language, which are preprocessor directives. So these are things that I've sort of borrowed from C languages, where it's, at the top of the program, you have like using this library, or some kind of direction to how the compiler should understand or sort of interpret the rest of your code. So I want to use that kind of idea to customize the way that the interpreter interacts with your code. So it would be things like, it would either be functional things like, I have this idea for like a palimpsest feature where every time you redefine a variable, it remembers its history. And so when you print it out, you can sort of hover over it and see what it's been in the past. Or something more emotional, like I've had this idea for like pound be gentle, and that would sort of customize the way that error messages are given to you. So I think that would be my plan for sort of bringing in more of the computational aspects of the language, but I have yet to develop that fully.
I mean, it seems like what you can do with this language, because you have functions, you have flow control, you can print things, and you have if conditions. So you can do you can do a lot of things. And maybe this is about the text output. Maybe it's sort of like it's a poem, and when it runs, it produces something else, like another poem or some other text. I mean, like if I were sitting down with this essaying, and I would be like, okay, well, what do I want to try to do? What can I try to do in this essaying? It's like, well, I'm not going to, obviously I'm not going to do something that's built around math, but it might be that what I'm trying to do is have one poem that generates another poem, or maybe a poem that generates another poem that generates another poem. That would be sort of my starting place if I were sort of experimenting with this language. It looks like you put a lot of thought into the way that this is displayed on the website. And first of all, I love the regex variable names. I think that works really well. You have I think it was stars to block out the comments. Is that right? I wonder if that's even necessary. Like, it seems like everything has to start with a command in your language. And I wonder if you just have lines of code that don't start with one of those commands, if it would just all read as a comment, and then maybe it will read a little bit more naturally as a poem without that. You wouldn't end up having that grayed out. So I'm not sure if it's important to you when people are reading the program to see those comments, treat those comments differently in terms of their reading of it.
I like that suggestion. Yeah, think about it. I was kind of fond of like those having typographical symbols like that. But I do like that is a good point that you point out that every line does start with a command.
So yeah, so there's some sort of initial thoughts with it. I'm wondering if others might have any comments about it, or any initial reactions.
We can open things up more broadly now. But again, I know there are some people probably who have to sign out at this point, sadly, but we'll try to we'll see if we can run this at least to the bottom. Well, no longer than the bottom of the hour, but that does give us a little bit of discussion time for people who are able to stick around and give some comments and some thoughts. I think, of course, nobody asked me, but I love this language in development. I love it as a meditation on our relationships between languages, variable and otherwise, as expressive environments of typography that have functions. And again, it just sort of draws attention even to that notion of the functionality of poetry. And I love this idea of the palimpsest. So again, it's like it just seems like a programming language, or that conceit, has given you an opportunity to meditate on so many aspects of writing, so many aspects of poetry, so many aspects of being. So anyway, that's my little blather, but let's open it up for questions. I don't know if people want to do hands. I can scroll back through I'll scroll back through the chat to see what people have said. But if someone wants to put up, we got a hand from Jeremy, so I'll take him first. Go ahead, Jeremy.
Yeah, this was wonderful, very thought-provoking, and fun. It seems like the sort of thing I would love to get my hands on and start playing with. Just some thought reactions. When you were talking about regex specifically, and the sort of intersection of aesthetics for you, it made me think of Wall's essay. I think it's around 1999. Perl is the first postmodern programming language. You might want to check it out. It's an interesting manifesto. And because Perl has this regexy character to it, in a lot of ways, I think there might be something interesting there about that sort of broader cultural thinking about what regexy code development is like, and how it relates to your project. So it's a bit of a long shot. But another thing that occurred to me was the tracery language. I'm not sure if you're familiar with tracery. It's used for chatbots, etc. Yeah, okay. So the pipe format, obviously, but also just the way that, like, thinking about how tracery is narrated as a tool, as part of a tool chain, rather than a language, right? And I also think very much so. Turing, you don't have to choose between being Turing complete and being a language at all, right? The concept of domain-specific language seems extremely helpful right here, right? That like this is a DSL, it's a domain-specific language, and you just don't have to apologize for that. You picked a domain and you're doing really interesting things in it. That's it. The very, very last thing I would suggest is look at oh shoot, what's the number? I have it right here. It's the look at the BIP39 word list from Bitcoin and blockchain. It's an interesting example of using either a predefined vocabulary or one that's filled using regular rules to then do numerics through a constrained vocabulary, right? So you've got, 1024 words. And if you want a particular number, you use one of those words. It strikes me that if you decided to go down the number route and you didn't want to take any of the paths that have been used before, that your approach might work really well with using something like restricted prefixes, like re or d or pre, at the beginning of a word, and then any letters that the person wants to put in the next part will be reducible to a numerical value, right, through like an ASCII operation or through a lookup table. And in that way, you have potentially a pretty big vocabulary of words that people can use, and there's a signal that things are getting mathy, and then you have like 30 different words that all mean 7, so just an idea. Like, I think you do not have to apologize for not doing math, but if you want to, some approaches like that might fit your aesthetic.
That's great. Thank you so much. Perl poetry, domain-specific language, and BIP39. Those are great suggestions.
Jeremy's comment reminds me to mention too Ink from Inkle Studios, which is another writer-friendly language that has brought out different things in my interactive writing. There's a lot of love coming to both of you through the chat, just in case you haven't had a chance to scroll in. I'm still looking for questions. We've got a question from Sarah. Let's have her go next.
Actually, I think Shanae's next.
Oh, okay, Shanae, you're next. Sorry.
Oh, I will be quick. I just want to say thank you, Catherine, for this and your work and all of the hard work that you're doing in both fields that both demand a lot of time thinking through lots of processes, and just wanted to acknowledge that, but also follow up on this thread of you were asking what would people using this want to see, how are you feeling like this might become more approachable or a way in, for example. And I know a little bit about code. Still, a lot of it sounds like confusing to me, but I do know a lot about poetry. And one of the things that Audre Lorde talks about, and there's actually a book that was just released of this for her seminars in Germany, specifically on like a poetry seminar and what poetry means, and what she's gifted to us is that, poetry is supposed to do this work outside of the actual poem, or like it's actually a thing that does separate itself from the writer, and it kind of goes off and does processes on its own. And one of the things that I wanted to just appreciate about the fact that there is no math here is that actually it has its own kind of like internal structure of what math is and what it can be. And I think when we think about Black feminist writing specifically, or just writing of I think all women and people of color through the ages, is that math is very much an auto theory math, and math is something that's abstract enough to be able to extend to something like auto theory. And so that's just something that I really received from your work, and hope that there might be a chance to build in some more of an expanded thinking of what math can be, especially in an environment where it demands you to define math. But the thing about Esolangs and the thing that you're doing right now is being able to define what code can be for yourself. And I think math really extends to that. So I just wanted to say thanks for that generosity in this flexible language, even if it maybe doesn't necessarily output something that you're sure about right now. And I think that's very much also in the spirit of poetry. So I just want to encourage you to keep that same thing and let the lack of definition that I and most other poets have live on in your code. And that would make me feel really able to approach it. So thank you.
Thank you so much. That was so beautifully put.
Yeah, I love that. Very well said. And that really resonates with how I'm feeling about every time I hear you talk about this work, Catherine. And now it's also making me think about it in a new way. So thank you for saying all of that. And I think that it connects with the comment that I wanted to make, or that tension that I kept hearing in Daniel's questions to you, and in the way that you were talking about this sort of, it felt, this maybe this imperative from this old coding paradigms for there to be the output or the privilege of this output. Like, what does it make? What does it execute as the real product of the thing, where you're shifting the focus to the experience of writing the thing, and the code or the script itself being central, both for the maker and the reader. So in this way, it's like, instead of it being whatever it prints out or it executes, the script itself is the thing that produces, whatever the poetic output is the effect on the reader, or the actual object is the script that was written much more like poetry. So I think it's interesting to kind of both to think about, a poem code that would output another poem code, which I'm totally into the infinite recursion of that. But I think that there's a lot that you could push against with that, and this way that we're always talking, or I'm always interested in how poetry, how writing is coding, is writing is coding. And you could live in that space a little bit too, and push back against that need for it to be Turing complete and focusing on the output only, because what you have and what you're doing is already so rich and is making a thing that you could say in that too.
I love that. Thank you for articulating it.
Yeah, that's wonderful. Daniel, that phrase seems like it comes up and applies to a lot of the Esolangs you're interested in. Coding is writing, is writing is coding. Something about that seems to resonate with a lot of what you were showing us.
Yeah, so I really didn't show examples of non-Turing complete languages in this presentation, but of course there are a lot of them, and many of the most interesting Esolangs are the ones that push back against kind of received ideas of what computation is. Turing completeness is not a requirement even for programming languages. Nobody really sort of there are many like the DSLs that were brought up before. Many DSLs are not Turing complete, but they're also still considered programming languages. So there are already sort of mainstream languages that are not Turing complete for many reasons. But it turns out there's also a lot of Turing complete systems that are not programming languages that people have created by accident. It's been shown recently that human heart tissue is Turing complete, and that's not a programming language. So there's this sort of, it's very hard to actually clearly define what is a programming language and what isn't. And many of the most interesting Esolangs are the ones that sort of sit on that border or sort of challenge those definitions. So I think that there are a lot of really interesting examples of that. But there aren't, while there are some great sort of poetic SLANgs, and Catherine and I both, it's funny that we both picked two of the same languages to show as examples for that, you know, which kind of shows that there's sort of a limited number of those, right? Because there was Shakespeare, which was kind of, you know, famously terrible. And then we have these sort of much more interesting reactions to it by people like Will Hicks. But so there's a lot of room to create a new poetic SLang that's really doing something different. So yeah, I don't think anybody's really sort of saying that you need to do something that's turn complete, or that math needs to be part of this. It's just sort of like this, you know, you are doing this as an act of coding. You want people who are writing the poems in your system to be coding in some way. So I think it just, we have to kind of figure out what that means for you, for those people to be doing code. If it's not going to be, you know, turn completeness is sort of the easy answer, because then it's sort of like they can write any code they want within your system, but maybe that's not what you want. Maybe none of this stuff is actually runnable on a computer, or maybe you can define that code to run on, you know, an impossible or self-contradictory computer that can never be built, if that kind of fits what your vision is. But I think that's just something that you're going to need to kind of reflect on a little bit about in what way this is code to you, and what the sort of behavior is of that code.
That's great. I'm going to pull a question from the chat. We've got Nick Lalone, who's asking, is there esoteric pseudocode? This is a combination of questions. And what is the candy land of esoteric codes where the code writes itself after an initial input? I wasn't sure if that was called a quine or not, but let's take, I feel like we need to unpack that first question. Is there esoteric pseudocode?
I guess I'm not sure exactly what that's. So I mean, pseudocode, right? I guess it usually means code that's similar, like something that's sort of code-like, that's sort of not actually meant to be run, but to sort of kind of make clear what code should do. I guess so. I guess the idea is, can you write pseudocode that isn't actually runnable in any way, that's sort of just for its own sort of beauty as sort of a esoteric system of thought, I guess. I mean, I like that idea. I don't really know what the answer is to that, if this exists or not.
Well, I have a question that piggybacks on that, perhaps, which, again,
Okay.
thinking about the difference between what counts as code, what counts as a script, what counts as pseudocode. What's the threshold? And maybe it'd be different. Maybe Catherine and you, Daniel, would have different answers, and everybody would have different answers. But what's the threshold, or I don't know, what is the criteria for something to be considered a code if it's not Turing completeness, for example?
Yeah, I mean, I like to say that for any definition of programming language, there's an SLang that sits on its border that challenges that definition, and that's why it can be very difficult to define, because once you define it, someone's going to come along and say, okay, well, here's something. You know, there's work by this mathematician, David Medor, who created, and he was not setting out to create an SLang, and maybe this isn't an SLang, but he created a series of programming languages for a class of computing that's more complete than Turing completeness, right? That can count to infinity, and that solve the halting problem, right? So it could do all these sort of impossible things, and it's a valid programming language. It's very well defined. It just requires an infinitely large computer to run. And since we can't build one in our universe, it's not a very practical language, but it still is a language, and it's and so there's sort of like, some people would consider that an SLang, some people would consider that sort of a theoretical language. So I'm a big fan of those sort of impossible languages, because some of those sort of challenge our ideas of computation in kind of some of the most interesting ways. They're called the hyper arithmetic languages. So I have this is to answer a question in the chat there.
Right. Yeah.
I interviewed David Medor for Esoteric Code. So he explains it a little bit in an interview, and he has stuff on his site, but his site is in French, if anybody's interested. So sorry, I'm kind of losing the thread of this here.
Yeah, but so the question is, though, again, like when does it what does it need to have then to get to be called a programming language? And it sounds like that feels like a question of sort of border control that is unnecessary for our discussion right now, or that sort of misses the point a little bit.
Yeah, I think there are many really interesting SLNgs that it's, some people would definitely consider not to be programming languages at all. There's a language called unnecessary, which I use a lot as an example. And it's a language that has only one possible program, and that program is the program that doesn't exist. So if you try to run it with anything, even with an empty file, it considers that too verbose, and it just won't run it as a program. But if you point it to something that to a path that doesn't exist on your machine, then it will run that program that's pointing to. And what it does is that program, that only possible program, prints its own source code to the screen. And since there is no source code, it prints nothing. So that's the null quine, the quine being the program that prints itself. So I think that unnecessary is, yeah, I'm a big fan of that language. And then there's the opposite language, which is called Callisti, where everything is a valid program in it. It won't reject anything, but all that it does is every single program just puts itself back out. So it really does nothing at all. So there's the one that's the all rejecting language, and there's the one that's the all accepting language. But there are many people who would say, well, there's no real computation happening. But of course, there is some computation happening in some way. And this is like, Nick Montfort has that null codes paper that kind of argues that even the empty executable will cause some computer operation to happen, even if it's just the machine complaining that there's no program to run. It will actually cause that error message to come up on the screen. And if that's all that you want to do, then that's it's doing what you need it to do. So yeah, I hope that answers the question.
Yeah, no, I think that does. And then there is a clarification that Nick Lalone gives in the chat that he's been in the pseudocode question, that he's been thinking about role-playing games and how there's a character sheet that a player, a setting, an idea represented in this combination of code that isn't run except when a check or dice is needed to check success or failure. Are there any character sheet based program SOLangs that you're aware of?
Not that I'm aware of, but that it wouldn't surprise me at all
Yeah.
that there'd be some crossover between those communities.
And again, we would be remiss to not mention again things you've written on non-English based languages. And again, that area of your research as well, that we have a mutual interest in the work of John Corbett, who was part of the most recent Critical Code Studies working group, who's developing his Cree-based language from the Métis culture. And I know you've written on other ones as well, Daniel.
Yeah, well, I really discovered his work at Haystack at the conference. Yeah. The presentation, you put that presentation together, and of course, you mentioned his work as well in your book. I have my copy right here.
Oh, thanks for that plug. Now this is the point where everyone gets to hold up their copies.
But the Flowmatic chapter in Mark's book really deals a lot with the sort of collision of I guess natural language and programming language, and programming languages that try to approximate natural language, or at least be more friendly to non-programmers by appearing to be related to natural language, and the sort of complications that arise from that. But yeah, so for Corbett's language, Cree Sharp, yeah, so I did interview him for Esoteric Codes, and it's I think one of the longest interviews that I've done. He really has a lot to say. He's done a lot of research on this subject, and his work is really, really fascinating. So I do encourage people to look at his work. But it really does challenge that idea that of having sort of a English dominated and not just that most programming languages are in English, but also that use sort of the Western ideas of logic, and he wanted to draw from storytelling traditions and systems of logic that come from Métis culture. And he talks a lot about the sort of the challenges of that, and also about not sort of accidentally bringing in ideas from that end up being sort of colonial ideas of that culture accidentally into his language, and being respectful of especially the elders of his culture, because part of Cree Sharp is that he wants to use it as a storytelling tool for elders to share stories, and so a lot of the storytelling techniques draw from their traditions. So his work is really fascinating.
In that way, it seems like there's a lot in harmony with what Katherine is sort of reaching for as well. I'm conscious of everybody's time. There's one event that happened this past week that I didn't think would speak so poignantly to our discussion, and that's the passing of Bell Hooks. And when I think about, the kind of theoretical work and the kind of life work that the operations that she inspired, and so many people, through teaching to transgress and on, and again, the way that has nice lines of flight intersection with people pushing back on computational systems, all sorts of systems. Katherine's system that's really, again, reaching out to the things that make life worth living, our relationship to symbols that helps us reach into emotion and the experience of being. And again, to me, there couldn't be a more noble purpose than that. And so anyway, with again, a little mention of her passing in the background, I just want to thank you all for coming today. I really enjoyed this discussion so much. And Daniel and Katherine in particular, thank you so much for just sharing with us. If we could give these guys some snaps, some claps for all that they've done for us today. And hopefully this is a conversation that that all of us can continue at a future monthly ELIT reading group, but maybe sooner than that in the Critical Code Studies Working Group, which starts on January 7th or 14th rather, and that will 15th, yes, that will have many of the folks that are listed in this Zoom as either present or facilitating or who knows what, and we'll see what more things we can dream up. So I hope you all have a wonderful end of the year and holidays, if you got any to celebrate, a wonderful new year, and I look forward to seeing you all on the other side. Thank you guys all so much.
Thanks.